Hi there, this is Ben Firshman from Docker. Had a little bit of drama setting up this meetup. We've had a power outage at the Docker office, but we've run to an office nearby. Well, apologies in advance if there are any technical hitches, because we had to run here and then had a minute to set up. But we're here and going to have a good meetup. What we're going to talk about, I'll share my screen here so you can see my slides. Going to talk about what we announced at DockerCon last week, and the huge amount we announced. So I'm actually going to sort of run through a lot of this quite quickly. Mainly going to talk about some of the open source products we released, but also touch on some new commercial products that we announced as well. Got lots of links off to places where you can find more information about some of these things. Also going to do some quick demos of the products as well. And particularly some of the demos that we didn't manage to fit into the keynotes we did at DockerCon. We've also got a bunch of breakout sessions that we did at DockerCon, which are now on YouTube. I've got links to those as well. All of these links and all of these slides will also be posted up on the Meetup group afterwards, so you can click on things instead of just looking at them. And I'll try and link off to some of these things in the chat as well. So to get started, here's the things we're going to talk about. Just a really high-level thing of the major things we announced. The two big new features which we announced in this version of Docker are networking and plugins. I'll go into more detail on those. We've also got a new ingredients initiative, the Open Container Projects, which is a new cross-vendor initiative to set standards for containers, and our two new commercial things, one which is Docker Trusted Registry and a preview of a thing that's in our lab called Project Orca. And on top of this, of course, we've actually had a whole new set of releases for Docker and all of the open source projects. Docker Engine 1.7 and Compose, Machine, Swarm as well, which I will touch on briefly. But these are the sort of headline things that we announced at DockerCon. First up is the new networking and plugins thing, or a new thing we're calling the experimental release of Docker. And this is, for a long time, with the Docker engine, we have very conservatively added stuff to it to maintain backwards compatibility. And because there's so many people using it now, since Docker 1.0, we've tried very hard to keep it stable and backwards compatible. But we also want to sort of work on new, bigger things and have people try this out without the risk of, once people try it out, we realize we might want to change some things without the risk of breaking that backwards compatibility for everyone. So we've got a new experimental channel with Docker, which is a bit like, if you use Chrome, it's a bit like the sort of beta and canary builds of Chrome, where they update more quickly, they might be a little bit more unstable, things might move around and change. But for people who want to live on the cutting edge, then this is for you. So these new networking and plugin features, we're actually releasing a new experimental release. And if you go to this URL here, docker.com/experimental, it'll have more information about how you can try out this experimental release. And just as sort of warning on this is like, don't use this in production. It's not necessarily that stable, but it is. It may well change. It's also a nightly build, so it will change unexpectedly. So only use this if you want to try out these new features. The first thing we're releasing on our experimental channel is Docker networking. And Docker networking is a huge new feature, which is complete rewrite of how networking is done, including sort of rethink of how networking is done in Docker. And this is actually the neat way of how the experimental build works. The networking stack in the stable build of Docker has actually been completely re-architected, built on, you know, the cutting edge, well, not cutting edge, but the best networking technology out there, but without changing the user interface. And this is all in a new thing that's also called libnetwork, where all of this technology is in libnetwork. As the stable release has completely rewritten new network stack with almost no new user-facing features. The only new user-facing feature is, I think, the ability to set the default gateway for a Docker engine, but everything else is under the hood quality improvements. But in experimental release, we've actually got a new user interface for networks, which sort of surfaces networks as a new top-level object, and lets you create any number of virtual networks and connect containers to them in any way. So you can essentially build topologies in whatever way makes sense for your application. You know, so if you want two containers to only be able to talk to each other, you can put them on the same network and they can only talk to each other and stuff like that. And it is just plain old level 3 subnets, layer 3 subnets, so you can do anything you can with them. It's not limited to single TCP ports in the same way that links are. And another huge thing about it is multi-host networking is built in. So you can create these networks across 2 different Docker engines on 2 different hosts, and they both share the same set of virtual networks. And on top of all this, we've also got standardized service discovery, which is using plain old DNS. So you know you don't have to change anything in your application to be able to use this, because you just reference hosts by name, and it just all kind of works. And also, which I'll talk about in a little bit more, is we've got pluggable backends. So it comes out of the box with, you know, a basic setup that works. But if you have sort of specialist requirements, or you want to integrate with existing systems you may have, or any custom systems that you have, you can plug in and out the back end the power networks. So from the application's point of view, it doesn't have to know what the infrastructure is, and on the outside, you can use all sorts of different infrastructure to run and support your apps. So, you know, in the same way that you can package up your application into a Docker container, all of the networking and service discovery in your application is now portable between infrastructure. If you want to go into more depth about this, there is a breakout session, an hour-long breakout session with loads and loads and loads of technical detail about how this all works up on YouTube. If you just search on Google for DockerCon networking, it'll come up. But there's also the link here, which we'll post later on the online meetup page. But I thought a good way of demonstrating how this works is to give a quick demo. This here. And so here's a terminal with the new experimental version of networking. And there's a new top-level command in the Docker client called network, which lets us do a couple things with networks. Lets us create or even list networks. So let's say I create a network called demo. And this will give me the network ID, sort of like containers. And now what I can do with this network that I've created is I can now start to attach containers to it. And then these containers that I'm adding to the network will be able to talk to each other. So I can use Docker run. I'm going to run something in the background, /d, and I can use this thing called publish service, which lets me publish this container as a service on this network. I'm going to call it Redis. Let's say what network it's on, sort of a little bit like a domain, a way of specifying what network it is. I want to run the Redis image and boot up, and boom, my application is running on this network. Now if I run a client, I'm going to run it in the foreground and use the publish service option again to specify what network is. So it's going to be a client on the same network. And just open up a bash shell. In this Bash shell, I can now access that container I created above. So I can ping it, and I can also connect to any port on it. And this is a new thing in Docker's networking. It's all IP based. So I can see this other container and all of the ports that are open on it. So I can just connect to the standard Redis port, and I don't have to worry about port mappings and what port number's exposed and what port number's on machine, all sort of things. It's just all the same port number everywhere, and it's just IP addresses that you care about. So I can connect to Redis on the standard port, and I have a Redis that works. And that's pretty much it. That's pretty much what networking is. And with this, you can sort of imagine how you can create that really flexible topologies for your applications and all this sort of thing. And that's the fundamentals. If you want to learn more about how all this stuff works, then again, this is the YouTube video of the breakout session with loads more information. So that's networking. Next interesting thing, which is kind of related to networking, is plugins. So I sort of mentioned just before that the functionality of the implementation of networks can be swapped out with different backends, and this is how it works. We've added a plugin system to Docker, which lets you swap out the implementation of how networks and volumes as well work without having to restart Docker or without having to compile it into Docker. It's completely out-of-band plugins. And because this is Docker, plugins are just containers. And in fact, it's a bit more like the sort of technical details of how it works is it's even more flexible than that, in that plugins are just a socket in a directory on the host machine. So, the easiest way is to put it inside containers, but if you don't want to put it in a container, you don't have to. You just have to open a socket on the host machine that speaks a really simple HTTP REST API, depending on what type of plugin it is. And if you want all of the technical details, then it's a breakout session which is coming soon, and all of the documentation is up on docker.com/experimental as well. And I thought the best way to explain this again is probably with a demo. So this time I'm going to show you how the volume system works. And I've got here two machines, one which is master and one which is a runner. And so what I'm going to do is I'm going to start a container with this new option here called volume driver. And this lets me define for this container what plugin is going to essentially provide the volumes, like implement the volumes for me. So instead of so I've got a volume here which is mounted into this container called test, which we mounted with path flash data. And instead of this being a directory on the host machine called test, this is going to be a Flocker volume, which is called test. So it's kind of the same idea, but instead of it just being stored on the host machine, it's actually stored in a separate system. And Flocker is a thing built by Cluster HQ, which is a way of doing container volumes cross-host. So I'm going to start this in. Take a second to set up the volume. And we can see here we've got a directory called data with nothing in it. Just like create a file in data, let's just contain a bit of data, hello world, and quit this container. What I can do is I can then go to another machine. So that's I did that very quickly. That started a container, and I've created a bit of data inside that volume that I mounted inside the container in flash data. So there's a bit of data now in a Flocker volume that's called test. And the nice thing about Flocker volumes is they can be accessible anywhere on the network. So I can start the same command on another computer here. So this is another computer on the same network. This is master and this is runner. I'm going to run the same command, the volume driver Flocker, and I'm going to mount the test volume from Flocker. Now take a second with transferring the data, and inside that directory we can see that data is still there. So thanks to volume drivers, we can access volumes across different hosts, which is quite cool, which is not a thing we've got built into Docker yet, but it's a thing that volume drivers let you do. And we've also got a bunch of volume drivers available today. There's Flocker, which Cluster HQ has been building, and also internally we built a Gluster driver as well, which lets you use the Gluster distributed file system. And yeah, that's what volume drivers are. So we can use volume drivers to store data in containers in various different systems, which is quite cool. And very important thing to note about this is the Flocker volume driver isn't compiled into Docker at all. It is, in fact, just a separate third-party system that was started at runtime, which is quite cool. So that's plugins. Cluster HQ and we have been building a networking driver. I've also put together this quite cool plugins demo, which is a video and a thing you can try out as well, which is a plugins-demo/2015.github.io. So if you're interested, head over to take a look at it. And you can also make your own plugins using this thing that David Calavera on our engine team made called BK Volume, which is essentially a Go library for writing plugins. A Go library that lets you really easily implement this HTTP API that plugins are. That is plugins, which is also quite exciting. Major new feature in Docker, which is in our experimental release, and will eventually make its way into the stable release as well, so you can try it out in production. So next up is sort of a initiative for what we're doing with a lot of the stuff in Docker. Is we want to start sort of a lot of Docker sort of originally started off as a sort of really neat little tool for essentially running containers and putting and pushing content. And as sort of Docker is building out into a platform, we want to make sure that we don't lose that essentially. And so we're starting to split out some of the content that's in Docker into sort of really simple standalone tools that do one thing really well. One of those things is runc, which is essentially a really simple tool that just runs containers. So you basically pass it a root file system and a JSON object that describes how the container should run, and it is run as a direct child process of that container, of runc, sorry. The container is run as a direct child process of runc. So, if you don't want any of the extra functionality in the Docker engine, if you don't need a daemon, if you don't need a REST API, or if you want to embed that functionality in another system, then runc is the thing to use. And it's up on GitHub here. You try out, and with an example of how you can start using it. And another ingredient we're releasing today, which is a completely new bit of functionality. And another thing to point out about runc actually is that eventually we are planning to build this into the Docker engine itself. So over time, the Docker engine will essentially call out to runc to run the container. And runc is also built on top of all of the technology we built for the Docker engine, which is called libcontainer. So it uses libcontainer directly as essentially a little wrapper around the libcontainer library. A new bit of functionality that we're working on is a thing called Notary. And this is something that's going to make its way into the Docker engine soon, but we thought we would sort of start this off as a ingredient because it's kind of useful on its own as well. And Notary is essentially a way of verifying content, of signing and verifying content. If you head over to the GitHub repository here, it's a good description of how it works. Essentially a client-server model. So with the client, you can sign and verify content and then store the keys in a server so other people can also verify that content. I'm quite excited by this, and this is essentially going to make its way eventually make its way into Docker as a way of verifying that pulled images are what the author intended them to be, and you can verify that that either Docker created that or the original author created that content, and it wasn't meddled with in the process of being transported to you, which is quite exciting. But that is going to come soon. If you want to sort of try out some of the technology, then head over to the Notary GitHub page. And on top of all this, you might notice this new GitHub organization in the runc URL here. We've also announced a new initiative at DockerCon, which is the Open Container Project. And this is a major new initiative from Docker and a whole bunch of other people as well, to define a standard format for a software container which isn't controlled by any one particular vendor. So Docker, as a piece of software, has obviously caught on, and lots of people are using it. But one of the great things about Docker is that it also defines this standard for containing a piece of software. And just by the sheer number of people who are using Docker, this has become a de facto standard for packaging software. But it's not a real standard yet because it's still owned by Docker Inc., the company, and still only really implemented and defined by Docker, the piece of software. But we want to turn this into a real standard, so it isn't tied to Docker, and that is what we've done here. And also got a bunch of other interesting new features with this standard is that it's not going to be tied to architectures either. So Microsoft and ARM are also going to be, and other architectures as well are going to be part of the standard. And it's going to be directly based on top of the Docker format. So obviously a lot of people are using Docker, and just by the fact that it's caught on and lots of people are using it, that it's probably somewhat in the correct direction. So it's going to be based on that. Also with a lot of informed by some of the standards efforts by CoreOS and so on, which are going to be incorporated back into the Open Container Project. This is quite exciting. This is a really, if you go to open.containers.org, you can see all of the logos and organizations that are involved in this project. We've got a really, really broad support from the industry for this standard. So from the point of view as you as a user or you as a consumer of the container standards, or building tooling or companies around it, we're pretty sure now that that this will, there won't be competing standards and you can just build on top of one thing. in the same way that with physical shipping containers, by the fact that we've all agreed on the size of the box that we're going to put stuff in, the whole worldwide shipping industry has worked and been successful. We hope this is going to do the same for the software shipping industry as well. So this is really quite exciting. And if you head to opencontainers.org, you can learn more about this. And another crucial point about this, which is where the ingredient story comes into this, is that we always want a working implementation of the standard, and that is runc. So Docker have donated runc to the Open Container Project as the running implementation of the standard. So you can always be sure that it's always based on working code and not just talk. It's actually based on working code as well. So that's the Open Container Project, and that is all of the stuff that we sort of announced at day one of Docker, which is all of our open source and open standards initiatives. Another thing I can give now is a sort of quick demo of how all these things tie together, and I'll give you a little really quick overview of what's in Docker 1.7 as well, which is sort of more details about this in the blog post here. And the main things obviously are networking and plugins. We've also got a bunch of orchestration updates as well. So a few little features in the Docker engine as well. If you want full details on this, then head over to the blog post here on the blog, and head over to the full release notes as well, which is in the documentation. And orchestration, the main orchestration updates were a bunch of, basically a bunch of features to make a lot of these things work better in production. A lot of optimizations in Compose to make things work faster, make things work more efficiently, more options in the Docker Compose.yaml as well. And for Swarm, pretty much complete support for the Docker API, which is very exciting. So pretty much all applications that run an engine should now also run on Swarm, which means that applications will just transparently work across multiple hosts, and also a whole bunch of extra stability improvements and new drivers and stuff like that in Machine as well. But the most exciting bit is the Compose and Swarm and networking integration. So previously with Swarm is a thing that lets you combine together multiple Docker engines so they appear as a one big single Docker engine. But now with networking, what's quite cool is the containers that are running on your Swarm on different hosts can now just transparently talk to each other as well, because we have built-in multi-host networking in Engine, in the experimental version of Engine. So I'm going to give a really quick demo of this to show you how it works. I'm going to open up a terminal here, make this a little bit bigger so you can see it. So I've got a really simple Compose application here, which is something that's probably quite familiar, which essentially runs a web server and a database and connects them together. And this is pointing at my development environment. And I can run this, a development machine that's running on my laptop, and I can run this on my laptop just using one command, Docker Compose up. If you haven't seen Compose and this is a surprise, then check out the Compose documentation, because this is a really great way of running applications locally on your laptop. And we can see here that it's aggregating the output from both of these containers, my Mongo database and my web server, so I can really easily debug it. And I can go to my dev environment here and see that it's running. So this application is just a really simple thing that counts how many times I'm viewing the page in MongoDB. And that's what it is. So let's suppose I'm developing this application and been developing on my laptop, and I now take it to production so I can show it to the world. I have a really similar compose file here, but with one crucial difference is that I've got a HA proxy load balancer that's sitting in front of my web servers. This is going to load balance against web servers as I scale it up. And what I've also got set up here is I've got a swarm set up, which I set up earlier using machine. So we can see I've got a swarm set up here. It is 11 nodes, 0 indexed, all running on DigitalOcean. And I've got my terminal here pointing at this swarm. So stuff that I run using Docker on this swarm will just be transparently scaled out across this swarm. So let's do pretty much the same thing I did in my development environment. Docker compose up. I'm going to use the -d flag so it runs in the background. And this is going to boot up my application on my swarm. If I go to a domain where this is running, which is hit counter.cool, quite a neat domain, and refresh this, we can see that my application's running in production. So basically taken with hardly any modifications to my compose file, and just with one command, I'm now running this application in production on a swarm. I've got a little visualization of my swarm here. The nodes are not showing up. Let's refresh this. Oh, someone says it doesn't work. Let's try and give it a dump. But if the visualization was working, here we go. So this shows the visualization of my swarm. We can see the HA proxy load balancer and my MongoDB database here on one node, and we've also got the web server here on a different node. And this application works, and these bits of my application can talk to each other because of Docker networking. So these containers are talking to each other across different swarm nodes, which each of these boxes represents, completely transparently and completely seamlessly from my point of view as the developer. But what am I going to do with all of this empty space in my swarm? Let's suppose my application is now blowing up on Hacker News and on Twitter, and I need to scale it up. I can use compose to scale it up. So we've got a scale command in compose where I can define, say, what service I want to scale, and say how many I want to scale up to. Let's say I want to scale this up to 50 web nodes. This is going to create 49 more containers on my swarm. Look at the viz, we can see all of these web containers start to show up in my swarm, all evenly balanced across the swarm, and my application just sort of keeps them working as it did before. And so yeah, that is how networking works with Docker's new orchestration, well, with Docker's existing orchestration tooling. So with one command, I've got my application up and running on a swarm, and with one more command, I've scaled up my application across my swarm, and I didn't, from my point of view as a developer, I didn't have to know anything about the infrastructure, and I didn't even have to know that all of this stuff was running across multiple hosts. With Docker networking, it just kind of works. So that's sort of a real example of how to use our orchestration tool and Docker networking together. If you go to docker.com/experimental, there is a composed swarm and networking guide here, which will show you how to do something similar to what I just did yourself, if you want to try out the stuff. It's all obviously still very early and very experimental, so please don't run this in production. But you know, if you like trying out new features and you want to sort of get an idea of how this might fit into your stack in the future, then please do try this out. Yeah, that's all of the new open source stuff. I'm also going to talk a little bit about some of our new commercial products that we announced at DockerCon, and then I think I'll hand it over to Q&A, which is sort of probably the more interesting bit and a bit that you probably didn't get a chance to do, well, that you don't get a chance to do when watching YouTube videos of the DockerCon talks. So the major new commercial products we announced at DockerCon was Docker Trusted Registry, which is a commercially supported version of the registry, which is the place where you push and pull images from. But it's also a on-premise version of the Docker Hub, which we host for you on the cloud. So if you want to host images yourself inside your own data center, then Docker Trusted Registry is for you. It's really easy to deploy and upgrade, and it integrates with lots of bits of your infrastructure, with all of your authentication systems and stuff like that. And we've also added role-based access control. So if there are only certain images that you only want certain people to access, and you can do that with this. It's available as part of our new Docker subscription package, and the Docker subscription package includes commercial support for the engine as well as long-term support for versions of Docker Engine, so you can deploy Docker Engine and get security and bug fixes without having to upgrade to new major releases of Docker. If you want more information about this, there's loads more stuff in the Day 2 keynote, which is linked to from here. And if you also want more information about our commercial products, if you go to docker.com/pricing, loads of information here about how you can get the on-premise Trusted Registry version and also the cloud version with support and repositories hosted in the Docker Hub. And alongside Docker Trusted Registry, we also announced the sort of thing we've got brewing in the labs at the moment, which is a thing called Project Orca. And Project Orca is really early stage at the moment, but it's the sort of thing we want to start getting feedback from you about, and how what sort of how you want to use it and that sort of thing. Project Orca is a opinionated way of running and managing containers in production. So we've been hearing from users that now you've got all these containers, now you're defining your app using Docker. How do you then run this stuff in production? And if you're really adventurous, you can sort of piece all of these things together yourself using a whole bunch of tooling. We've also heard from a whole bunch of users that you really just want something that just works, and somewhere where you can just run containers. That's what Project Orca is. And Project Orca is both a opinionated top-to-bottom stack for how to run containers using Compose and Swarm and Engine, and it's also a GUI on top of that for managing it. And it works across a whole bunch of different clouds, so you can deploy containers in loads of different clouds, as well as your own data center. And the best way to learn more about this is towards the end of this keynote video here, which is linked. Evan Hazlitt gives a incredible demo of how this all works. So if you're interested in this sort of thing, I invite you to go and check this out. Yeah, that's sort of really I mean, as you can tell, so much stuff happened at DockerCon. This is a really quick overview of all of the things. Going to link to these slides after the after the presentation, so you can sort of click on all the links and sort of go more deep into the stuff that you're interested in. Also, we're pointing out that if any of this stuff is interesting, we are hiring at Docker, and we're looking for a whole load of technical and non-technical roles, working on everything from web development to low-level system stuff. I'm working on Go and working on all the open source tooling as well. If you're interested in stuff, please go to docker.com/work-docker. I'd love to hear from you. And now I think I'll open this up to the floor. So thank you for thanks for listening. If you have any specific things that you want to talk to me about, my email is bfirsh@docker.com, and also Twitter bfirsh. If any sort of questions you think would be of value to the wider audience as well, I'm now going to start taking some of those questions. So thank you. Just switch here to be able to see what the questions are. Brilliant. I'm just scrolling back and seeing some of the questions here. One of the questions is, will runc support plugins? So maybe. The engine is one of the things we have in engine is a exec driver model that lets you swap out different backends for running containers, which currently supports libcontainer, which is the same thing as runc, and also LXC. We're planning to add other backends in there as well. So Microsoft are working on a backend for Windows containers as well, which is quite exciting. runc at the moment just supports Linux containers, but depending on where we sort of want to draw the lines with plugins, there might be support in runc for also swapping out the functionality there. Specifically though, it will always support the same definition for defining containers, which is the open container spec for containers, and that is always going to be the same regardless of what backend is actually powering the containers. So somebody asked about the multi-host networking with Swarm. This works with the latest version of Swarm, but you do need to run the experimental engine binaries to power Swarm, if that makes any sense. So it's the stable version of Swarm, but you need to run the stable version of Swarm on the experimental version of the Docker engine to make the demo that you just saw work. This is all explained in detail on docker.com/experimental in the guide on how to do that stuff there. So if you're interested, then check that out there. So one question is, does multi-host networking only work with a single swarm? So one neat thing about multi-host networking is it's actually detached from, it's sort of separate from Swarm. So if you want to use multi-host networking with just engine and piece together, combine multiple Docker engines yourself, that will work just fine. And we're going to add sort of more flexible support to Swarm for networks as well. But this is sort of a little bit of the way that networking demo that I showed there. It's a little bit of sort of configuration in Swarm that just makes containers that you start in a Swarm transparently be part of the same multi-host network. But over time, we also want to add more flexible support for networks to Swarm as well, so for support for multiple networks and stuff like that, which Swarm doesn't yet support. Let's see. Another question. Somebody asked, will runc support multi-version container formats? I'm not sure what that question means, so if you can clarify that, that'd be helpful. Somebody asked, can Flocker be used to sync volumes in place of BitTorrent sync? At the moment, this was a plugin just demonstrating Flocker, and Flocker just has, natively transports volumes around. If you want to use BitTorrent sync for Docker volumes, I don't think this exists yet as a plugin, but because of plugins, you are totally free to write your own plugin that supports BitTorrent sync. That's actually quite a cool plugin. So if you're interested in that, then you're free to work on that. Are there any more questions? I think actually somebody else asked, is Docker experimental installation working on OS 10? You can't run containers on OS 10, so that's nothing new, but you can use the Docker experimental binary as a client on OS 10, and that works fine. And somebody asked, is there a Docker tool for visually looking into containers? The Project Orca is in fact going to be a GUI for looking at containers and all that sort of thing. There's currently no Docker tool for doing that. There might be third-party things. I can't think of anything off the top of my head at the moment, but it's worth a search on GitHub or something like that if you're interested in finding something. But all this sort of stuff can be built into Project Orca. So Project Orca will work as a GUI, sort of an overview of your complete infrastructure and of Swarm and how your containers connect together and all that sort of thing. Right, so question from David here who clarified the previous question. If the container standard changes, will runc still support multiple versions? And yes, that is something that we're building directly into the new open container format. Is essentially in the JSON object, which is the container metadata. There is a version field, so the thing that's running that container will know what version of the standard it should be attempting to read, and both runc and Docker will support that versioning. I expect that there'll be a certain sort of deprecation policy here. So runc might not support container versions forever, but the intention is for it to be relatively stable. So runc should be able to run containers. The nice thing about the open container format is it's a relatively small, simple standard. So if you define your software using this container format, hopefully you won't have to change and update that over time. You can package it up as this container and it will keep on working everywhere for a long, long time. So yeah, that should work, and that should be transparent from a Docker perspective as well. Cool. So last chance, I'm going to give this another minute if anybody wants to ask any more questions that get in your questions. But thank you very much for listening. And if you want to hear more about all of the stuff that I talked about, I would suggest you go and listen to the DockerCon keynotes, which is essentially what I talked about, but a bit longer. It's about 4 hours of content, all of this stuff. I'll in fact get the links to you now and paste them into the thing so you can see them. Well, I can't. Here we go. Here's Solomon's keynote, which is day 1 with all of the open source stuff, and wait, actually that might not have been it. Sorry about that. So day 1 keynote is this link, and and the day 2 keynotes. Where's my next go? And the day 2 keynote is this link. And all the slides will be up on the keynote page, on the meetup page afterwards as well. Thanks very much for listening, and hope you enjoy exploring all of this new stuff that we announced. A whole load of new stuff, I do realise, but it's all very exciting. Thank you very much.